Hi, my name is Tomoko, and today I will be presenting to you my Mars colony design project. Here's the drawing of the model I made for the Mars colony. In the next few moments, I will be explaining each aspect of the design. Please enjoy. First, we will start with the housing or shelter for the astronauts. We need a house for our colonizers, and we are assuming a dozen people, so 12 people. There will be 3 houses. Each house will have 4 people living inside of it. And as the drawing shows, the houses will be implemented in a circle so that the houses face each other as one community, encircling the big greenhouse in the center. The material of the house would be basalt composite mixed with a plant-based polymer. This model can easily be made on Mars as there are a lot of basalts there due to volcanoes, and the houses will be built with a robot that would 3D print the model. It will act as an effective shield against high-energy radiation on Mars, which is 50 times greater than it is on Earth. The structure of the houses will have a rounded and smooth shape to handle stress from pressure differences between the interior and exterior. It will also have an airlock system in which the system needs to be very airtight and work perfectly every time to prevent carbon dioxide and other gases in the Martian atmosphere from getting inside, as humans are only able to breathe oxygen to stay alive. In addition, underground tunnels from each house to the greenhouse in the center are added to make it easier for the astronauts to contact and/or socialize if they wish to. And the tunnels are obviously also pressurized and filled with an artificial atmosphere made from nitrogen and oxygen. In each house, there will be multiple floors, each with a distinctive purpose. Floor 1 will have the wet lab and space for extravehicular activities, also known as EVAs, preparation. Floor 2 will be where the kitchen and dry lab are. Floor 3 will have the gym and recreation center. And finally, floor 4 will be for the bathrooms and sleeping quarters. Of course, the house that the colonizers would be staying in will include window installation, as it is key. It allows for a relationship with the environment, and since the landscape changes on a daily basis, it helps to mitigate monotony, which is a major psychological threat. There is also a garden to grow plants and animals, as a lack of vitamin C can cause vitamin deficiencies, which can lead to a number of other health problems. Humans also need fresh food in their diet to enhance happiness and well-being in the orbitory laboratory. The garden or greenhouse will be in the center of the community. Here, it will contain a hydroponic garden and aquaponics. We also have to keep in mind that the food needs to be grown in Mars-like light intensity, but Earth-like atmosphere, because they would struggle to survive in Mars' thin and cold and dusty atmosphere. The reason for the hydroponic garden is that we cannot simply go out there and plant seeds because the topsoil of Mars is very toxic. Everything is desiccated and dried out. Also, some of the typically iron-rich leafy vegetables like kale and spinach might take up excessive iron from the Martian soil, and too much iron in our food can cause indigestion or even food poisoning. Therefore, the soil underneath that which contains carbon, hydrogen, nitrogen, and oxygen and phosphorus, and bring that into a greenhouse and start growing food in hydroponic chambers, probably underground and using LED lights. The patches will be about the size of a carry-on piece of luggage and typically hold 6 plants, with probably have 12 patches, 1 for each person. Each plant grows in a pillow filled with clay-based growth media and fertilizer. Pillows are important to help distribute water, nutrients, and air in a healthy balance around the roots. Otherwise, the roots would be either drowned in water or be engulfed by air because of the way fluids in space tend to form bubbles. It may also be possible to take microbes to make meat using synthetic biology. Again, not only does the greenhouse serve as a place to grow plants and raise animals, but because of its big size, it can also be a place where the astronauts come and socialize with each other. Now we have water. Water is essential to life. Where there is water, there is life. Although there are no large standing bodies of liquid water on Mars, below a layer of dry dirt, there is ice. To get water on Mars, we can take that water, take the ice and clean it, take all of the sewage out and treat it with chemicals for safe and clean drinking water. Scientists even say that it is cleaner and safer to drink than tap water. The water can also be used as a fuel source, apart from being the water to drink, brush your teeth, etc., as it is made up of hydrogen and oxygen, which are 2 components of rocket fuel that can help sustain the astronauts on Mars. Power in this case will be supplied by solar power, while a hydrogen fuel cell provides backup power in the case that the levels run low. Because we will need to be getting around to places on Mars, there will be 3 transporter storages, 1 for each house. As you can see in the drawing, the storage will be kept close to the houses for easy access. To ensure that all houses can access this, there will be an underground tunnel, which is also airlocked, to the storage. To rest up, each house will have a room for the astronauts to sleep in. Each room has 2 beds, mattresses, and stools, as well as a space under each bed for clothes to be stored. There will also be a 3D printer in the habitat to enable the crew to print new tools if they need to on a future mission on Mars. To prevent the crew from getting claustrophobic while inside the habitat, the dome has a large ceiling. The 4 people will be split into 2 groups to share a single bedroom. The toilets and showers will be in the bathrooms on the topmost floor along with the bedrooms. There will be 2 showers and 2 toilets per house to minimize waiting time and just in case the other one breaks. Furthermore, there will be 1 communication tower approximately 20 meters away from the houses. This will be 20 meters away to prevent any frequency from interrupting electronics in the household or brainwaves. These enormous antennas enable humans to reach out to spacecraft millions of miles away. The larger the antenna, the stronger the signal and the greater the amount of information the antenna can send and receive. Last but not least, we have the launch pad, which will be installed 5 kilometers away from the houses, which is a safe distance to prevent any damage from the pressure when the rocket launches.